so we just have to go along with it. I do it because sometimes they are set up a little strange. So according to a study, the mean cost of bariatric weight loss surgery is $21,500. You think this information is correct. You randomly sample 25 bariatric patients and find the mean cost of their surgeries is $20,695. From the past studies, the population standard deviation is known to be 2250, and the population is normally distributed. They told us this because our N is only 25. So they had to tell us that this was normally distributed. Now, keep reading with me. Is there enough evidence to support your claim? So here's the key. Support means, the word support means we're going to have an HA as a claim. The word reject means we're going to have an HO as a claim. But however, this is where your claim came from. Your claim. What is your claim in this case? What would our claim be according to this? Theirs is not the same as 21,500, so he's saying it is not equal to, right? It is different from. It's a little bit confusing when you read this. So his test data, he still tested his data off of this. This is his test information. We're going to leave his test information for a minute because usually your claim doesn't come from your test information. But normally, according to the study, we would say this is equal to this, right? But because we're supporting this person's claim is from his own data, which we never make a claim from our own data. We either work off of what the study says or what someone said or disagree with that or something. So the fact that it's a support means we have an HA. So when it comes to this guy, we don't want the equal sign. We want to say, well, I found this information. Mine is different from the 21,500. So a little bit different in writing this. Again, population parameter for mean is mu. He's saying not equal to 21,500. Does everybody see that? It's totally the way I would not write this. If I was writing this, I would say, you randomly, you think this is incorrect. You think it is different than 21. I would say that right in my words. You think it is not 21,500. They were just missing that statement. The reason you tested this is because you disagreed with it. So you think it is not 21,500. And the way they say support your claim, support has to be an HA. Don't ever put their test information into their HOHA. That's different. So again, did I already do this? Did I start this? Yeah. Okay. So again, this is a little differently than I would do. I would have added another statement. You disagree with this study. You think it's different. But they didn't put it in there, so that's one of those little assumptions we have to make. Now, we found this, so we know this is our HA. This corresponds with this piece. Anytime we have an HA, we use the word support. Okay? Anytime we have an HO, we use the word reject. So that's going to help us tie in here. So the opposite, the complement, complement of this is my HO. This is what my study says. I disagreed. I did not think it was 21,500. I thought it was different from. It's basically what we're saying. It's implied. Okay. Okay, so now, we pull out your test information. This is the test. This is your test, what you did, what your sample said. Your sample said you sampled 25 bariatric patients. Their mean was 20,695. Your population standard deviation from another study was 2250, because in this one, we have to know what the population is. And we're adjusting this for the central theorem, the central limit theorem. We're saying 2250 divided by the square root of 25. This is going to make my standard deviation a little smaller, a little narrower. It's going to give me a little bit more space in there. Okay, so now we sketch. Is this a right tail, left tail, two tail? Two tails. So I've got a test statistic here, a test statistic here, and I have a test statistic here. So I need to figure out where this number comes from. So I say, okay, I'm going to use your z-score formula. In case you forgot, we have to do this thing here. So we're going to say, we have a claim. This also is what we're looking at. 0.05. Okay, so we're taking your test minus their population mean. Put your standard deviation in here. Be careful the way you divide this out. Use your alpha key to make life a little easier. Use your alpha key and you get negative 1.79. So if this is 1.79, negative 1.79, this is positive 1.79. Okay, now, in a two-tailed test, it gives you a little extra space. These are symmetric. It's the same area on both sides. So look up the negative number. It is the area to the left. It is this shaded little piece. When we do the next part, where we actually have critical values and we see it on the graph, it'll start to make a little bit more sense. But look up this space. This space right here is 0.0367. So is this space. So we're going to take that space and we're just going to multiply it by 2. This is your p-val. The value, the probability value under your curve. Your area under your curve adds up to 1, your probabilities add up to 1, and they're interchangeable, probability value with area. Okay, the next thing we're going to do is test. You're going to test your p-val against your level of significance, just like the top of that chart says. Your p-val is 0.734. Your level of significance, 0.05. Fill this with the same amount of zeros as your space. Spaces are 734 greater than 500. So we look at our chart. What is our decision? Fail to reject HO. This is so important, guys. HO. Well, let me come back here, because my claim, my thing that I'm claiming is not my HO, it's my HA. So watch what happens. If I fail to reject my HO is saying they're equal to. Is my claim valid? No. I'm failing to reject this one. My claim is really not holding water here. But I can't interpret it that way. To interpret it, I go back to this chart. I say my claim is my HA. I failed to reject my HO. So my final answer says this. There is not enough evidence to support my claim that the bariatric cost of surgery is different from 21,500. I'm saying it's different from. They're saying it costs 21,500. There's not enough evidence to support my claim. So let me write this again. I'm going to write this out. There is not, we're going to follow your chart. To support, this is important, it's got the support word in here, of the claim that the cost of bariatric surgery is different from or is not equal to, if you want to put not equal to in there, that's fine too. It's a little backwards the way they did this. I'm not fond of the way they did it, but it's good to address because sometimes they see it a little differently. Okay, so the interpretation part is the most important. And you actually should say that it's at the level of significance of 0.05. When you do this, if you want to change the word to say, some of my kids over the years don't like my English people, the English majors, say there's not enough evidence. When you say insufficient evidence, absolutely, you can say insufficient evidence. You just can't change that around too much because it's got to look like that. Now, your calculator has a wonderful, wonderful test for this. So we go to stat, we go to test, and so far we did all your intervals down here, but because we're testing, it's right up there on top. Because it's a z-score, we're sitting right up there on top. It's a z-test. Now, a little difficult to interpret, but we'll put this through. The mean sub-zero, that's your original mean. That comes from your statement. This guy right here. This is from, technically not their claim, but it is our claim that it's different from. So there's your 21,500. Okay? Your standard deviation, that came from the problem, 2250. Your sample came out to be 2695. Your N, how many did you sample? 25. Okay, now, your tail, these are the tails. The tails go by the HAs. What it says is this, just follow whatever symbol this is. So right now it says not equal. If it would have said less than, I would choose the less than. If it would have said greater than, I would choose the greater than. This one tells me it's not equal. It goes by the HA, whichever way it's set up. Because it goes here, this mu, less than this guy. Mu not equal to this guy. So I'm going to come down there and I'm going to calculate. Now, it gives me a couple of things. It gives me my test statistic. Right here, this is my test statistic. And it gives me my p-val, which I just wrote right over. So right in here, this is my p-val. Notice it already multiplied it by 2. I don't have to multiply it by 2. It gave me the p-val that I need to use. It gave me my test statistic that I need to use. So for those of you that like the calculator, it's a nice, easy one. It sits right at the top there, z-test. And right underneath it, we do next, t-test. So, nice way to look at this. Test statistic, p-val. In a little while after we get through being comfortable with this, we're going to test with the test statistic also. But right now, I just want you to get comfortable with doing this. Questions at all? All right, you guys are going to try the next one. So, my sketch. All right, what does my sketch look like? Two tails. Good. Okay? Shading on both sides. Big shading or little shading? Little areas on both sides. Okay? So I know I've got a two-tailed test. I'm going to pull out my test information. How I test this to see. My mean from my test is what? 3.3. My previous standard deviation here is 0.5. Now, my sample standard deviation uses the central limit theorem. Says 0.5 divided by the square root of n. And n was 25. So it's going to make that be a little bit smaller. And if you put this in your calculator, give them your 0.5. They calculate it, which is probably what you did, right, Sarah? You calculated it. Sarah put it in, calculated this out to 0.05, moved the decimal one place, whatever it was, and came out way too small. Okay, so now we got our test information. Your next step is your z-score. .3 minus 3. It could come on either side because this is a two-tailed test. 0.5 divided by the square root of 25. You get a z-score of positive 3. And that is fine. So this is your test statistic. There's a negative 3. Now, you want the area in the tails. If you look up the 3, you get this big area here. You're going to have to subtract it from 1. So just look up the negative 3 and get that little area out there, which is 0.0013. Your two-tailed test says multiply by 2. This is your p-val. We did all of this to find out that p-val. Now we test. We test p-val. I tested in this order. Level of significance, 0.01. Level of significance. So your p-val and your level of significance. Fill this with zeros. It makes life a lot easier to compare the numbers. 26 is less than 100, and the less than also uses the equal sign. It is the smallest, this is the smallest allowable error that I'll make, and no more extreme than that. Remember, this is very small, so I don't want it to be an unusual situation. Okay, so now what is my decision? Chris, what's my decision?
There's not enough evidence.
Yeah, interpretation. My decision. Reject HO, fail to reject HO.
Reject the claim.
Just say reject HO. It's got to be this. Now your interpretation says, okay, claim is HO. I rejected it. So let's look at this logically. This was my claim. I rejected this. So now I'm kind of having to say, it is really like not equal to 3, right? I have to kind of agree with the not equal to 3. But I can't say it that way. I come over here. My claim is my HO. I rejected it. I didn't agree with it. My evidence does not agree with it. So I say, there is enough evidence at a level of significance of 0.01 to reject the claim that the time to recoup the cost of the bariatric surgery is 3 years. That's my final statement. That's my statement to whoever asked me to research this. They don't want to hear reject H0. They don't want to hear reject, but they want to hear it in words. There's not enough evidence to reject the claim at a level of significance of 0.01 that the time to recoup the cost of surgery is 3 years. And that's what you'll give to somebody. And your calculator, again, the calc is nice if you want to use your calculator. Stat test. Z-test is sitting right there. Your mean, this comes from your population. That's what's in your statement here. That's got to come from your HO or your HA. Your standard deviation, that's my 0.5. Your calculator will calculate and divide by this. Your X bar, 3.3. Your N stays the same, your tail is the same. Notice, there's my Z-score, my test statistic. There's my, if I round it, I get 0.0027. Round it a little bit better because your table rounded and we multiply. So 0.0027, and that's what you're going to compare with. Okay? So if you use this, you can bypass this piece, and you can bypass this piece, and you're going to go right to this. Still got to give me your sketch. You can take this right out of your calculator. I'm going to tell you what your test statistic is. Questions at all on this? No? You know I'm giving you a book assignment now. This is a big one. This is a big one. Page 373.
The announcement, the Lisa Morano, the GBP 4972 that's parked out front of the building needs to be moved immediately. The Lisa Morano, GBP 4972 needs to move immediately.
Okay. So you're just going to do these two to start. It's just going to give you a sketch, have you find your p-val, make you make a decision. There's not like a lot to do on those two. These, you're going to do exactly what we did on these. But you're going to set this up same way. I want all the steps. You're going to do a p-val test. If it says critical region, don't worry about the critical region. We do that next. But right now, all I want you to do is the same thing we've been doing here. Use your p-val test. Good? Make sure you write these down.